Okay. So I'm trying to connect what we're seeing now, to what we saw in the previous section, graphs of lines, equations in two variables. And really, again, what I'm saying here is point slope form is an equation, is one way of writing an equation of a line. Okay, to write any equation of a line, you need the slope and a point on that line. And through point slope form, you can get an equation of that line. Okay, and it's actually a generalization of what's called the slope intercept form. Before we get to that, let's get an equation of this line. Okay, so how do we do that? Well, we need 2 points on the line. And yes, I labeled these 2 points, mostly because these are the points I'm going to use. But do I have to use these 2 points? No. I can use any 2 points I want. I can use this point. It looks like the point there is 0, 1.5. So I can use this point, and I can use this point if I want. This looks like to be -1, 1. I just need any 2 different points on the line. It's just, I just labeled these because I'm sorry, what? What was that? Did someone say something? I thought someone said something, so, okay. All right, but anyway, what do we need? Well, we have 2 points on the line, okay? So I chose these 2. But again, to get an equation of that line, we need the slope, right? And again, even before we do the calculation, we can see that if we move to the right horizontally, this line is going up. It's rising. It's rising as we move to the right. I mean, it's pointing northeast. If you think of this as north and this is east, like on a compass. You think of it that way also. So we know at the very least, the slope has to be positive. Okay. So we have these 2 points I chose. So what I did was, I did 2 minus 0 over 1 minus -3. Again, 2 and 1, they're from the same point. 0, -3 are from the same point as well. Good. So we have 2 minus 0 over 1 minus -3, which is a half. And so if this is positive, that's good. That's what we want. If we subtracted in the wrong order for some reason, we would have a negative slope, and we would know something's wrong. And that's actually what I'm saying down here. That if for some reason, we subtracted incorrectly, as I'm doing here, we get a negative, but again, that's impossible from the graph. So an equation of the line, again, it doesn't matter which of the points I use. I could even use a point on the line that's not one of these 2 when writing an equation of the line. But I'm using this, if I use this point, I would get y minus 0 is a half, that's the slope, times x minus -3. And it's better to write minus a negative as plus, so that's why I get this. Y minus 0 is just y, so that's over here. That's if I decide to use this point. If instead I use this one, then we get this. Y minus 2 equals the slope. The slope doesn't change, times x minus 1. So it doesn't matter. If you were to graph either of these, you're going to get the same line. Excuse me, let me say it again. If you graph this and you graph this, you would get the same line. And again, this is just saying what I said before. If we made a mistake and somehow got a negative number here, such as subtracting in the wrong order, well, then we would know something's wrong. From the graph, we saw the slope had to be positive. Even from the points, we can see it had to be positive. I mean, lines are very nice like that. Now, if you increase x from -3 to 1, so if your x coordinate gets bigger, we know those y coordinates have to get bigger, meaning the slope had to be positive. Okay. Okay, now we get to the form that I find most students really like, the slope-intercept form. It's actually a special case of point-slope form. Namely, slope-intercept form, again, if the slope happens to be m, right? And the y-intercept happens to be b. Again, y-intercept b, that means it passes through the point 0b. Then this is an equation of a line. The graph of this, in other words, is the line with y-intercept b and slope m. And I put an example here for fun. I didn't graph this, not yet at least. But let's consider these 2 points. We want the line passing through these two. Notice if you increase x from -2 to 2, the y's are going up as well. So if we increase x, the y's are increasing. So even before this calculation, that should tell us the slope has to be positive. But it does turn out to be by this calculation, right? So we have 8 minus 0 over 2 minus -2. That's 8 over 4, which is 2. Again, coordinates for the same point, they're on top of each other, as you can see. Same thing over here. 0, -2, they're from the same point. Now we have the slope. Are we done yet? Well, if we're using slope-intercept form, the answer is no. So if I asked you, let's say, find an equation of the line in slope-intercept form, yes, we have the slope, but we got to figure out what b is. How do you do that? Well, we know these points are solutions to this equation since they're on the line. So if I plug in either of these points into the equation, so to say, then the equation has to hold. So in other words, if I replace y by 0 and x by -2 as here, this equation has to be true. It has to hold. And that's what's happening here. So let me go say that again. So we have to figure out what b is if we're using this form. All we have is the slope, m. But these points are on the line. So these are solutions to this equation. So if I replace x by 0, y has to be -2. And if I replace x by 2, y has to be 8. So we can use either point to figure out what b is. I'm using the first one because there's a coordinate with 0, right? So if y is 0, and then x has to be -2. So we have this equation. And from here, you can figure out what b is. Namely, you get -4 plus b is 0. So b has to be 4. And this is our equation. So in slope-intercept form, we have this equation. The line is the graph of this equation. Well, I did graph it, in fact, here, as you can see. Okay, and I'm pointing out some other stuff here that's very useful. Notice that if x happens to be 0, y has to be 4. I mean, you can easily get that from the equation. But that also tells us that the 0.04 is on the line. That's down here. What happens if x is 1, though? Well, if x is 1, right, by direct calculation, we get y has to be 6. So 1, 6 is also on the line. But notice this is kind of interesting that this is saying if I increase x from 0 to 1, so if I increase x from 0 to 1, notice the y values are changing. Well, they're increasing, right? The new y value is 2 units bigger. 2 units bigger. So the y value, the y coordinate, is increasing by 2 units. And 2 is the same as the slope. The slope is 2. This is why we say the slope of the line is a rate of change. If you increase x, not just at 0, but anywhere, your y values will increase by 2 by the slope. The y values change by the slope. That's why it's called a rate of change. And that's anywhere. So if I went, let's say from x, here I went from 0 to 1. I mean, I didn't show it in the graph, but if I went from 1 to 2, right, the y here starts at 6. The new y value would be 2 units bigger. 2 is the slope. That's why the slope is also called a rate of change. I mean, you could do this for lines, but most functions you cannot do this for. Not easily, at least. Okay, here's another example.